Now it's telling me the haloalkane. I've got alkanes that have halogen, maybe chlorine, bromine is there. Can either undergo elimination or substitution. Now remember, elimination, you are removing, something must go out. Am I right? And you're forming double bond or triple bonds. Substitution, you are simply swapping puma wena, ngena wena. So you start with the single bonds. So here they say, okay, let's just read. In the presence of a strong base, no problem. They say study the flow diagram below, which represent two different reactions. So that one, the first one there, because it's given, I'm going to break it down. So it's called, at the end, it's called butane. Butane is 4. So that means I've got map, yeah, 1, 2, 3, and then 4. All right, then, okay, I want my carbon to be, they must look straight, not funny. Okay, let them be there. Yeah, this will be carbon number 1, carbon number 2, carbon number 3, carbon number 4. It's butane, single bond. We good. Now, in number 2, you've got a bromo. In carbon 2, there's a bromo. So, which means I can put here Br down there, bromo. And then also in carbon number 2, you've got a meth. Meth is 1 bond. So down here, I think it's visible. Let me use blue. Yeah, blue is better. You got meth, 1 carbon, C, and then it's going to have 3 hydrogen, 1, 2, 3, or you can write it as CH3. So that's what we have. So the rest, this one must be up, down, left. I'm breaking it down for you to actually see how they look like. And then the next one, this one will have a hydrogen there. Down there, it will have a hydrogen. The last one will have up, down, left. Hydrogen there, hydrogen there. This is structural formula. They might ask you to do structural formula. Now, now check what's happening. They say it is dilute with strong base. Remember, anything that is a base starts with something. It ends with an OH. Understand?
Yes, sir.
Yeah. Because when you do acid and bases, you know it must be OH. So one of them, it can be HOH, which is water. One of them can be, let's see, what can it do? All right, let me show you. I think I've got periodic table here. Just hold on. Let me check the periodic table here so that I can make you how to memorize strong base. Okay, if you want strong base, you make a chair, my friend. Your chair comes like this. And then it goes like this. It's like an H. Do you see that?
Yes, sir.
All right, the first one is what? It's lithium. So when you're dealing with lithium, these are strong base, all of them. It will be lithium hydroxide. That's one. Let's go down. Number 1, you've got sodium. So the next one, it's sodium hydroxide. That is strong base. The next one, you got K, potassium, KOH, hydroxide. The next one, it's rubidium. You got rubidium hydroxide, but hardly do you get there. Then when you come to group number 2, you've got calcium and selenium. So that means you take Ca, because it's group 2, it will be OH subscript 2. And then when you do selenium, it's going to be selenium OH. And then 2. These are a strong base. So when they say strong base, they are using one of these guys. Are we good?
Yes, sir.
Okay. Now we can go back here. But what you know, you already know there is an OH. So that means, let's say I was to do this. If I were to write plus, let's call it X, and we go OH here. There is no way here you can put OH inside here, because that is single bond. So that means there's no way you can have single bonds here. I mean you can substitute there. So that means somehow you must eliminate it or whatever, because you don't have double bonds here. You're not breaking double bonds. You want to form them. You want to make these double bonds. Can you see that? Are we together?
Yes, sir.
So in your case, that means you must get rid of that red and one of the hydrogens. Let's say maybe here. When you do that, to have a double bond here, so it's going to tell me the Br can go with an OH, it can go with one of them. The H goes with one of them. Look at that H. H can go with an OH. Br can go with the first one. Remember, if it was strong base, let's say we're using sodium hydroxide. I'm just giving an example. Let's say it was Na. So that means Br can go with this one. It can form sodium bromide, and then the H can go with an OH, meaning H2O. It could be that, but you don't do all of that. All right, I'm just trying to show you. We will be forming double or triple bonds. All right, so there we go. Okay, now the other one I need to, because I'm taking your time now. The other one, they say concentrated. Oh, no. Sorry. Let me say what I said that I misread the thing. This one, these are the strong base, okay? Strong base. Sorry about that one. I said it is strong. They say diluted strong base. So when it's diluted, it's no longer really concentrated. It's not really strong. So those ones, these guys, you can say they belong here. Diluted, it means it has water. That's why you could see here, we're going to have water. So you can take the little one. Remember, when you add water, like water by itself, it's a weak acid. All right, so you'll be having acid and acid. So you're having these guys. If you take them as they are, they'll be strong. But when you say diluted, you are adding water on top of them. Okay. All right, but let me not go further here, because they'll ask you the type of reaction that takes place in 2-bromomethyl is heated in the presence of diluted strong acid. They want diluted here. Maybe they can ask you in a strong one. Then we need to know, is it elimination or substitution? Remember, if it's elimination, you must have double bonds already here. You don't have double bonds here. So that means what's happening, it must be substitution, swapping them around. Okay, let me give you a nice good night's sleep.